Good morning, Mrs. Virgo here, and I want to welcome you all back into TUSD TV channel station. Today I would like to teach you some science, and so we're going to be doing some multiple experiments. Ask your parents before you go around the house getting supplies and things, but these are all simple things you can do at home safely. Before I begin, I would like to introduce you to a friend that I brought with me. And over here we have the grad scientist. So I want you to welcome her, and she will be here to help me explain things scientifically. Thank you. I'm happy to be here. Thank you for joining us. I'm ready. Okay, so boys and girls, I want to start with talking about the properties of water. There are some unique qualities in water and things we can learn from them and how they help us in our everyday life. And so one of the properties I want to start with today is called surface tension. And I will let the grad scientist give you some more details on that. I want to get down and get my hands wet and start doing some experiments. Okay, so for the first one, it's called how many drops can a penny hold? And for this, you will need a small glass or cup of water. You will need maybe a paper towel or something to sop up any water. And these are small amounts of water. You will need some type of dropper. I found an old medicine dropper, an eyedropper, even a syringe will work if you can, work it slowly to get drops of water. So these are the things that you are going to be using. Even a teaspoon will work. If you take a teaspoon, you can drip water off the teaspoon. So you'll need that. Of course, a penny. Give me a penny here. So I'm using wax paper for my surface, and wax paper works the best. But if you don't have wax paper at home, you can try parchment paper. It works for a little while till it gets a little too wet. Change it out. You can use saran wrap. You can put saran wrap down. I've taped my wax paper down right here. Another idea is just a clear sleeve or a white sleeve here. Okay? So with all these different materials, just make some choices. Use what you have. You don't need to buy anything. You don't need to do anything extra. So for the first experiment, how much water can a penny hold? So the first thing I'm going to do is, of course, take a penny. And I'm wondering, I have two pennies here, and they look very different. I'm just going to randomly select. This one looks a little bit older. And so I want to know how many drops of water I can put on this penny without the penny overflowing. I think I will use this tool right here. And so that is 1 drop. Now, I'm going to look at it for a minute because I think this would be a great time to make a prediction of how many drops of water that penny might hold. So I'm going to think about it for a minute, and I want you to think about it as well. How many drops of water before it overflows? Oh, excuse me, the phone's ringing. Hello? Good morning, Gil. Yes? 3. You think it will hold 3? Why 3? Okay. Okay. Thank you for your prediction. 3. Excuse me. Hello? Hi, Danity. 100. You think the penny will hold 100 drops of water? Okay. Why do you think that? Okay. Thank you for your prediction. Watch and see what happens. So 3 and 100, that's quite a difference. Let's see how many it does hold. My prediction, I think I will go in between. I'd say about 50, 30. Okay, we have 1, 2, 3, 4, 5, 6. Oh, it's getting big, but it's still on there. 6. Okay, sorry, Gil, we went above 6. Do you want to make another prediction? Do it in your head. 6, 7, 8. Oh, it's still holding. I'm getting a little bit nervous. 8, 9, 10, 11. Whoa. I want you to observe what's happening. Everyone look at it physically, the properties. What is happening? What do you see? 11, 12, 13, 14, 15. Oh my goodness, I see the whole thing moving. Okay, anyone, any boys and girls, if you want to change your predictions now, it's the time to do it. We were at 15, 16, 17, 18, and my water overflowed. Carefully observe before you sop up the water. Observe what you see. 18. So I'm going just to take a little paper towel and I'm going to just sop up the water right here. There we go. Okay, 18. But I'm wondering how this penny held 18 drops of water. Think about that. Now, scientists always check their experiments more than once because you look for different variables. So I'm going to try the new penny. Let's put the new penny right here. Let's make a prediction. Okay, here we go. 1, 2, 3, 4, 5. Whoa, 6, 7, 8, 9, 10, 11. Take time to observe. 12, 13, 14, 15, 15. I'm curious. This penny held 18 drops of water, and this penny held 15 drops of water. Why do you think it was different? Think about it. Excuse me. Hello? Well, good morning, Joshua. The older penny? Thank you. Thank you for your observation. So Joshua thinks the difference is because one penny was new and one penny was old, and he said that maybe one of them might be worn down a little differently. Let me think about that. That could be a variable. Excuse me. Hello? Leslie? Yes. Nice to talk with you. Okay, thank you. Leslie says I used 2 different droppers to put the penny on, and that might have made a difference. I used the smaller dropper and a bigger size dropper, and so she is predicting that the size of the drops made a difference. So boys and girls, I want you to try this at home and make your predictions. But in the meantime, let's hear from the grad scientists on what happened and why.
Thank you, Mrs. Virgo. Great experiment. That was a lot of fun. Okay, so we are dealing with water molecules. So water molecules, another name, the scientific name for water is H2O. And because molecules are made up of atoms, in water molecules it is 2 hydrogen atoms and 1 oxygen atom. And so molecules work together. Okay, so this is a water molecule, otherwise known as H2O for water, because of how the molecules are made up. Now, hydrogen atoms in water molecules bond together. Okay, the bonds get stronger closer to the surface. So these are all water molecules, and when they are sticking together, we call that cohesion. The adhesion means stick, and co means join together. We call this cohesion. Okay, these are through hydrogen bonds. So closer to the top, as the molecules build closer to the top, it begins like a tight a tension because they grab even tighter. There's more molecules up here, as you can tell. We call this surface tension, tightness on the surface. And this explains why bugs can walk on water from the surface tension. So here, water molecules adhere or stick to other water molecules, and hydrogen bonds form. We call this cohesion, which also creates a surface tension. Thank you, Mrs. Virgo. Can we see some more?
So thank you for your input, and we're going to start with the next experiment just to test this theory about surface tension and about cohesion, water molecules sticking together. So I have a cup of water right here. Move my penny. A paper clip, just a small paper clip. And then, so I'm just going to use my tweezers because I don't want to touch the water because I don't want to break surface tension for a different purpose. So I'm just going to use my tweezers, and I'm going to set the paper clip into the water. Can you make a prediction of what you think will happen once I put the paper clip in there? Okay. And there goes the phone again. Excuse me. Good morning. Hi, Madeline. You think it will sink to the bottom? Because the paper clip is heavy. Okay. Thank you, Madeline. Okay. Excuse me. Hello, Juan. Nice to talk with you. What do you think is going to happen once I put the paper clip inside the water? Do you think it will float? Oh, because the grad scientist said that surface tension might hold it? Thank you. Watch and see what happens. Okay. So some of our viewers feel like it will float and some feel like it will sink. So let's test this theory. Here we go. So here we go. It's sunk. Now remember, we say that in science we have to experiment more than once to make sure other variables aren't into place. So let's try it again. It's sunk. So let's try this again. And it went right down to the bottom. Wait a minute, it's floating. Look at that paper clip floating. Let's make some observations. We always have to make observations. I think I can see that surface tension that I recognized from the top of the penny. Interesting. Why did it sink one time and it floated another? Let's think about that. Scientist grad, can you help me with this one? We're looking at surface tension. The bonds forming high on the surface. Okay, so according to scientist grad, that is surface tension holding the paper clip. And the first time I took the paper clip and I had too much air, or I dropped it right into the water a little bit further away, and so the surface tension was broken. And so the paper clip went straight to the bottom. The second time, scientist grad said that I very carefully set it on top where it had a chance to, the molecules to grab together and float. So that makes me wonder, if I were to add another material, say like soap, can I break that surface tension without touching the paper clip? Make your predictions in your head, everyone. Think about what you think will happen if I touch a little bit of soap in there. And I'm just using some hand soap, some dish soap from home, because that seems to be the best for scientists. Make sure it's safe. Make sure you have parents' permission. So here we go. I'm going, excuse me, I'm so sorry. Hello? Mom, Mom, yes, I borrowed the dish soap. Yes, yes. I will bring it back and, Mom, there's no dishes in the sink. Okay, I gotta go, bye. Okay, so now let's continue with our experiment. And I'm just going to take a little Q-tip here and open my soap. And I'm sure it might not take much, so I putting a little bit of soap in there. And watch carefully. Putting this out of the way. Let's see if I can drip the soap in here or touch the water with it without touching the paper clip. Okay, there's a drop of water in the soap. And I'm watching, there's a drop of soap in the water. Silly me. And I'm watching. Paperclip's moving. Let's do it. Let me touch this again without touching the paperclip. Wait for it. It's moving. Let's go again. So right now I see soap floating and I see the paperclip floating. Do a little bit more. So the surface tension is clearly holding that paper clip floating. And think about that concept. The weight of a paper clip, made of a type of metal, is floating on top of water. So it's being held by the surface tension. I'm going to put a little bit more in there. And wait for it. Wait for it. And there you go. The paper clip dropped. And again, I'm going to defer over to my colleague here, scientist Grad, to explain what just happened. Thank you, Mrs. Virgo, but I think you did a very good job at explaining that and displaying how the molecules at the top of the surface you showed us, they get tighter and it holds the weight of another object. We do call this surface tension, and it is the molecules, the cohesion, the hydrogen bond of the water molecules. Nice work. That was a really quick explanation, but it makes sense because we have been talking about that. And you called that adhesion, with a different material breaking the surface tension. The molecules of the water combining with molecules of a different substance. And in this case, the soap broke up the surface tension. Okay, so we learned that surface tension is a property of water, and it is almost like an outer coating. Surface tension. Tension means tight, and surface means outer layer. So it's a tightness on the outer layer because the molecules, that's what scientist Grad said, because of the molecules, the water molecules have hydrogen bonds, and we call this cohesion. And then when you introduce a different material or different molecules, then it's adhesion. We added something else. Adhesion again means stick. We added something else that it would stick to. Okay, so boys and girls, what we did today was we tried how many water drops will hold on a penny, and we also experimented, can a paper clip float? And we learned about surface tension, about cohesion, and a little bit about adhesion. So if you try this at home, make sure you have an adult's permission to gather your supplies together. Would you like to have any final words, Grad scientist? Any final words for our audience? Now, that is Grad scientist. In my final summary, I just want to remind you the surface tension, the tightness on the top from the cohesion of the hydrogen atoms in the water molecule, and adhesion when we're adding other molecules to the sides. So we started with surface tension because of adhesion, and now we're talking about because of cohesion, and we're talking about adhesion. We will talk more about that next time. Nice job, Mrs. Berger. I agree. This was fun. Until next time.